Watts are a very useful tool for describing a specific kind of energy consumption, right? So we can talk about a watt and we know we're talking about newtons and joules and the amount of energy it takes to move a certain amount of force per second, right? That's that idea of a watt, is it's a regular per second utilization. However, it's an absolute descriptor. And another way that we're going to refer to power and energy that is associated with Wi-Fi is going to be using the term decibel. Now, you might be familiar with decibel in a sound context, right? So we talk about going to a rock concert and how many decibels it is, or you go to the Seahawks football stadium and how many decibels are they generating. Well, what we're talking about in that context is referring to the original use of decibels, which is a baseline of 0 describes the threshold of hearing by the human ear. And then, relative to that baseline, we can describe how with more power, we get greater volume. With less power, we get less volume relative to that baseline. It originally came up because Bell Laboratories was trying to figure out a way to describe the loss of the sound signal over miles of line. And a bell, the original unit, was actually based upon starting with 0 as the threshold of hearing and then saying, okay, how much signal do we have after a mile? It was a relative change in distance. The interesting thing about this is that it can be used to describe any kind of change in power. And so we're going to see it used in Wi-Fi. We can be talking, but we'll see that there's several different flavors of decibels. There's decibels relative to hertz. There's decibels relative to joules. There's decibels relative to a lot of different systems, because the decibel is simply the description of power change, the relative measurement. It's a logarithmic scale. And because of that, in order to convert, say, from watts to decibels, what we find is that we measure raw power in terms of watts. And as we double the power in a logarithmic scale, we find that we end up reaching a decibel level of 3. If we have 10 times the power, we move up to a logarithmic value of 10. Now, the reason why that's useful is because if you don't have a calculator, we're going to find that there are some ways that we can convert from watts to decibels in terms of relative usage compared to a baseline based upon this system. The inverse is also true. If you have the power, you're at negative 3 decibels. If you have a tenth the power, you have negative 10 decibels. So decibels, relative measurement of power utilization. Remember the rules of 0, 3, and 10 apply to 0, 2, and 10. So power first, decibel second as we look at this particular system.